I'd like to do a quick review on summation notation. We also call it sigma notation. And the reason we call it sigma notation is because it uses the Greek letter sigma. So this is my general formula for sigma notation. And we say that this is the sum of all terms a sub I. That's what I mean, a subscript I, when I say a sub I, where I is from 1 to n. So in this case, this thing is the Greek letter sigma. And if you ever see this letter in any math class, it's going to mean sum. The 1 is my lower limit. Occasionally you will see your lower limit start at a different number, like 0 or 2. And my n is called my upper limit. So if you don't understand what this formula is, that's fine. I think you'll probably get it a lot better when we do a few examples. So for these examples, we are going to be finding the sum. And for my first example, my lower limit is 1, my upper limit is 4. The function that I have is I to the third power. So all this means that we're doing is we're going to be doing 1 to the third plus 2 to the third plus 3 to the third plus 4 to the third. We calculate all those out, we add them all together, and when you get your answer, you should get 100. So basically what you're doing is you're starting at the first whole number, you go up by increments of 1 to the highest number, then you add everything up together at the end. For my second example, go ahead, pause it and try it on your own. Okay, so for this one, my lower limit is 4, my upper limit is 7, so make sure that you actually start at 4. My first term is going to be 4 times 4 plus 1, which is 5. Second term is going to be 5 times 5 plus 1, which is 6. Then I have 6 times 6 plus 1, which is 7, and 7 times 8. If you multiply everything out, you should get 148. For number 3, there's actually 2 ways that you can do this problem. You can do it the same way that you were doing the previous 3, which is just taking 3i and plugging in 1, 2, and 3. That's the first way to do the problem. But you can also do that. So if you do that, by the way, you end up getting 3 plus 6 plus 9 plus 12, which is going to give us 30. You can also, however, take this 3 that's in front of the 3i and bring it out front. You are allowed to do that. It makes the problem a little bit simpler. Then you just get 3 on the outside. 1 plus 2 plus 3 plus 4 is going to be 3 times 10, so it still gives you 30. Now, for this type of problem, it doesn't really matter which way you do it, but if you get something more complicated, it's nice to be able to pull that constant out. One other type of problem that you might see is something like this. If you see something where you have just a constant, you don't have anything to plug the 1, 2, 3, and 4 into. So my first term is just going to be 3. My second term is just going to be 3. Third term is 3. Fourth term is 3. So the answer for that one is 12.